Hey, what's up, guys? Today we're gonna be looking at this integral. It's a fairly complex, but it's a fairly complex integral, but once you understand the sort of the inner working of how you need to approach it, it's really like it just kind of opens up and lets you like get the answer. Um, I know two ways of solving this. The second way, it just gets around doing u substitution initially. Um, I know you're probably thinking to yourself, wait, how do you do u substitution? There's no derivative. Well, you'll see. Um, so yeah, let's just get into it. I'll show you just the straight up u substitution first, cause it's a little bit easier and it's more intuitive. It's cause it's just straight up u sub. First, you need to set it to x+1 because u sub is inside of the u is inside of an exponent. You can't have du inside of it. Du is equal to 1. And then here, what we want to do is we want to set x equal to u minus 1. As you can see, this is true. So this is equal to u minus 1 integral. Summa sign, it's called, times u 1/2. Now you want to just distribute. And at this point, you might think, oh, well, there's nothing you can do here. Oh, you just subtract the two and then just do power rule. Um, no, you need to apply linearity. And by doing that, you split this thing into two integrals. Um, this is kind of the crux of the thing. I mean, obviously, making x equal to u minus 1 is the trick. But I mean, you can do that, and if you can't get past this, you're kind of screwed. Um, as I've always said, calculus is about splitting things up as much as you can and making them into um, parts that are simpler. And that's exactly what this is doing. It turns this equation, which is near impossible to solve. I think this is like impossible without using like non-elementary shit, um, non-elementary methods. But turning it into this is a lot. It just makes it, it turns it into power rule, which is like every like baby's first integral rule. So so that's what we'll do. So just solve these independently of each other. So 2/5 u 5/2 minus 2/3 u 3/2, and then looking back up, u is x+1. Just gonna plug back in. So 11, lol, 3/2 over 3. So this, you can multiply by 3 up here and you get 6 minus, actually screw that, I'm not going to. Um, I would not recommend that you do it. I'll do it actually. It's really convoluted. You multiply through and you get this times this plus this over 3/2 times x plus 1, 3x minus 2. Yeah, whatever. It's convoluted, and it's not, don't do this unless you can like instantly see that this is your answer. Don't even attempt this. It's really, I mean, you can attempt it all you want, but like on a test, I'm trying to draw brackets, whatever. On a test, I would never even attempt this. I would be completely fine with this because this is a right answer. So I'm gonna show you that other method real quick because I think that it is potentially like you know cooler. It's harder for sure. It's definitely harder. least I think so. What is it? X plus 1 square root of x plus 1 dx. Okay, so essentially what you're going to want to do is just rewrite x plus 1 as x plus 1 minus 1. Or, I mean, x is x plus 1 minus 1. Um, so to do that, let me think about this for a second. Let me look at my notes real quick. You're going to want to rewrite this as square root of x plus 1 times x plus 1 minus 1 times square root of x plus 1. So we're not changing the stuff inside of the square root because we literally can't. If we do, it's not this. Well, I mean, it is the same. It's just, but okay, because we can't take the plus 1 outside, so there's nothing that we can do with it. So I mean, these adding it there literally doesn't matter at all. Since it's inside the square root, we can't do anything if we add it because we can't get it out of the square root. So as you can see, I just did this, and then I moved this over there. So so yeah, I split it. Is what this is called, splitting. So then you're gonna want to apply linearity. It's kind of like we did the first time. Actually, no. What not yet. You're not going to want to do that yet. You're going to first. You're gonna want to just distribute these two, and then minus square root of x plus 1 dx. So this is all I did was distribute these. I made this. I just set this square root as 1/2, and then just started going in. Um, so I did 1 plus 1/2 because these are the same base. So you can, and since you're multiplying, you can just add. And this has a exponent of 1. This has an exponent of 1/2. You add them together, you get 3/2. Okay, so now we want to apply linearity. I kind of forgot about that one trick, or that one thing that you have to do. You have to do that, or else you're not going to get the right answer, so I guess it's good that I caught it. Okay. I'm fairly sure that you could add these and keep the negative inside here. Why you would do that, I don't know, but it should give you the right answer, I would think. So then you're just going to want to solve these independently. I'm going to set u equal to x plus 1 here, just because it's u sub. So u times 3/2. This is where you basically just start doing that one method, the first method that I showed, times du. This is going to equal, yeah, this is just the same from before. Duh, I mean, I guess. And then x plus 1. And then for this one, you're just going to want to you're going to want to keep the same u. So, square root of u to the 1/2, which is 3/2, so 2/3 u to the 3/2, and then minusing these two, so and then we want to plug back in our u, so which was x plus 1, so 2/5. Let me write this in a different color because this is our answer. X plus 1, 2/5 times x plus 1 times 5/2 minus, or to the 5/2, 2/3 x plus 1 times 3 halves plus c. This is your answer. And that's how you do integral from the antiderivative of x times the square root of x plus 1 dx 2 different ways. Thanks for watching.